Guys, in this video we will discuss about that how can we test the convergence or divergence of a series by Cauchy root test. So let us see about the statement of Cauchy's root test. So the statement of the Cauchy's root test is that if un greater than 0, that means all the terms of the series are positives, and if limit n tends to infinity, un whole to the power 1 by n is equal to rho. That means the nth root of the nth term is equal to rho, where rho is a finite quantity. Then summation un will be converged if rho less than 1, and summation un diverges if rho greater than 1. And when rho is equal to 1, then the test is inconclusive. That means we cannot say about the series is convergent or divergent when rho is equal to 1. So the statement of the Cauchy root test is the series is positive terms, and the nth root of nth terms is equal to rho, and then the series un will be converged if rho less than 1, and un diverges if rho greater than 1. So now let us see one problem about that use root test to examine the convergence of the following series. So let us take the first problem, that is 1/3 plus 2 by 5 whole square plus 3 by 7 whole cube and so on. So now we can say that, so now we will try to solve the first one. Next I will solve the second one. So given that 1/3 plus 2 by 5 whole square plus 3 by 7 whole cube plus so on. So from here we can write that the nth term un is of the form n by 2n plus 1 whole to the power n. So from here you can also say that if you put n is equal to 1, you get 1 by 2 plus 1, so you will get 1 by 3. If you put n is equal to 2, so you will get 2 by 5 whole square, and similarly so on. So now we have to find the nth root of the term un. So un whole to the power 1 by n is equal to, you can write limit n tends to infinity n by 2n plus 1 whole to the power n into 1 by n, and after simplification we get limit n tends to infinity n by 2n plus 1, and if we more simplify then we get half, which is less than 1. So the value of the rho is a half, that means rho, and the value of the rho is half, which is less than 1. So first we consider that the series will be convergent by Cauchy root test if rho less than 1. So now we can say that the series is convergent by root test. So now solve the second one, that is summation find the convergence of the series wherever un is equal to n plus 1 by n whole to the power n plus 1 minus n plus 1 by n whole to the power minus n. So now from here we can write that un is equal to 1 by n plus 1 by n whole to the power n plus 1 minus n plus 1 by n into whole to the power n. So now let us take that n tends to infinity un whole to the power 1 by n. So simplify, we get n plus 1 by n into n plus 1 and minus n plus 1 by n. So if we take now n plus 1 by n common, we get 1 plus 1 by n after simplification, and we get 1 plus 1 by n whole to the power n minus 1. And as n tends to infinity, this term will be 0, and we know that this is e, limit n tends to infinity. It is limit n tends to infinity 1 plus 1 by n is equal to e into e. So we get the value 1 by e minus 1, and which is obviously less than 1, and we can, and since if that value, that is the simplified value of limit n tends to infinity n whole to the power 1 by n is less than 1, then that is convergent. So we can say that the series is convergent by Cauchy root test. So I hope you understand that how to find the convergence and divergence of a series by Cauchy root test. So thank you.